Alright, in the last video we just talked about writing chemical formulas for molecular compounds, and this one is going to be looking at ionic compounds. Now with ionic compounds, remember that's between a metal and a nonmetal, and those elements are transferring their electrons from one to the other. When they do those transferring of electrons, they create ions, which is why they're called ionic bonds. But each one of those elements have, as you see in this chart here, an oxidation number. You have some elements like those transition elements here on the periodic table, those elements that you see here in the orange here. These elements are transition metals, and the transition metals, a lot of them have multiple oxidation numbers. So some of them can be +2 or +4 or +6 or negative this, that, and the other. Their oxidation number change depending on where they are or what they're bonding with at the time. So it varies. But most of these other elements, the elements that you see in group 1, 2, and 13 through 17, those elements oxidation numbers, not all of them because there's a few that have multiple, but for the most part those elements and those groups have a set oxidation number, meaning they will only either gain such amount or lose such amount. So here is a list, and this list can be found in PLP, and I believe it's found in lesson 49, possibly lesson, I'm sure it's lesson 50 if not 49 as well. You can find this chart and it tells you the different elements and it tells you their oxidation number that they have. This is going to be important, and you're going to need this, okay, when doing the what we finna do now, the crisscross method. Now if you look at group 1 elements, remember group 1 elements have one valence electron, and because it has one valence electron, it's a lot easier to get rid of one than it is to try to pick up 7. So what it's going to do is have a positive charge because it's going to lose that one electron. Any element with 4 or less is more than likely going to get rid of those 4. 4 and above going to gain 4. Now the reason I say 4 both times is 4, it takes the same amount of energy to gain 4 as it does to lose 4, so they can go either way. It just depends on who and what they're bonding with, I should say. So it just depends on what element or what compound is being formed. But for the rest of them, anything less than 4 will always be a positive, meaning they're going to lose electrons, and anything more than 4 will always be negative. Those elements that you see here are going to gain electrons. They're going to pick them up, okay? Now when we look at the crisscross method, you're going to take your elements, any element that will form an ionic bond. Only thing that you're going to need is the oxidation number, and you're going to need the element symbol in order to do this. So just for a quick example, that same example that we ended out in with 10(2), okay, 10(2) and oxygen. Now 10 we learned is SN, and because of this 2 here, this is one of those that have a multiple oxidation number. It can be 10 + 2 or it can be a +4. So that's why you have to signify which one you're actually working with. So in this case, +2, oxygen, -2. Once you set up the oxidation numbers, you do what we call crisscross. The +2 is going to come as a subscript for the oxygen. The -2 is going to come as a subscript for the 10. You do not bring the charge, only the number. Notice, I only brought the number down. Okay, so when I rewrite this as a formula, it's going to be SN2O2. Now notice, we can simplify. Both of these are 2. You don't have to use both. Write down the 2. You want to simplify that. Alright, and when you simplify it, that's how come we ended up with SNO, because 2 can go into both of these in order to make it simple. Real quick, just another example. If we have calcium, calcium is in group 2, so it carries a +2 charge. And let's say we have fluorine. Fluorine is in group 17, so it carries a -1 charge. Y'all moving too much. I'm making a video. Hold still. You'll be alright. Now, you take this crisscross, 2 comes down here, 1 goes here. All right. When you rewrite it as CaF2. Okay. So any one of these ionic compounds would be easier to write just by looking at using the crisscross method, taking your oxidation number and putting it down as a subscript for the opposite element. Okay, and that works for all of them. All right. If you have any questions on crisscross method or how it works, just message me.